So let's talk about compressed natural gas. Maybe give us kind of the definition and kind of some of the supply chain pieces in broad strokes for those who may not be familiar with it. And I think we talk about LNG. That's kind of the hot topic. Maybe differentiate from that and talk to us about the supply chain of CNG.
So LNG and CNG are both two methods of transporting natural gas, a sufficient volume to make it worthwhile. Because as we know, natural gas has traditionally been transported by pipeline. So on the compressed natural gas side, what we do is we accept the gas into large compressors. They're 500 horsepower twin compressors. We go through three stages of compression, and at each stage, the gas is cooled because as you compress, it gets very hot. And we compress that gas into tube trailers. So our trailers are basically 45-foot trailers they have 4 cylinders inside them. So the cylinders are 40 inches in diameter, 40 feet long, and they contain basically the energy equivalent of 10,000 liters of diesel, 14,000 liters of propane, or 9,500 cubic meters of natural gas from an energy equivalency. So our natural gas for us always remains in the gaseous form, and so we truck it that way. When we get to a client site, we haul anywhere between 3,000 and 3,800 psi in our trailers. So obviously that's too much pressure for a client to use. So when we get to a client site, we have what we've designed in what we call a pressure reduction system. We call them PRS. And basically what that is a series of boilers that heat glycol, and then a series of heat exchangers, gas to glycol heat exchangers and regulators. So we connect our trailers to these pressure reduction units, and we drop the pressure, and we regulate it to what the client requests. So in doing so, basically we've taken the gas from a high pressure, reduced it to a low pressure, and we can regulate that. Now, when we bring our trailers to site, we don't offload into storage tanks. We leave our trailer. So we connect every trailer to the pressure reduction unit. The pressure reduction unit will sense which trailer is full. We'll pull from that one, and we'll stop pulling from that trailer when it gets near empty. So we set that switch point based on the client's load and the client's pressure demand. And so before the PRS stops pulling from a trailer, it establishes the flow from the second trailer. Once that's established, then it shuts off the first trailer, and then we get the signal to move away.
Okay.
So we come and get that trailer, and we refill it. Now, from an LNG perspective, LNG basically it's a similar process, but instead of compressing, what they are doing is they're cooling it to a point below -100, and I'm not sure the exact number, when it becomes a liquid. So they haul as a liquid. So the advantage of LNG is that you can haul more of it in the trailer. So if you're hauling long distances, and our general cutoff, we would say, is maybe 450 kilometers. So below 450 kilometers from a hub, CNG tends to be more cost effective. If it's further away than that, then LNG starts to gain that advantage because there's less trucking involved. So you'll often see LNG for very remote sites or for shipping via sea. So if you're going to fill a tanker, you might as well fill it with LNG because it's a liquid. You can get more of it in a load. So the two are basically the same end, but it's a different way to get there.